In this video, we are going to talk about an example from section 3.1. We're going to introduce ideas from section 3.1 on the marginal concept. Okay, so prior to this point, we have talked about problems that you should know how to do. You should know how to take a function f of x, and you should be able to find f prime of x. Usually that will happen with Maple. You should also be able to, from a function, you should be able to find a tangent line to this function f of x at a given value, which we call x is equal to a. And the formula there is clearly f of a plus f prime of a times x minus a. And we gave that a name called L of x for tangent line, right? And then you should have also, given a function f of x, you should know how to find f of x plus h approximately, where, x and h may be given values, okay? So we've talked quite a bit about the formula there, f of x plus f prime of x times h, okay? So we have an example over here on the screen, which I want to talk about now, that kind of does one more example and then transitions to the marginal concept from section 3.1. Okay. So the example that we have on the screen over here is we have a function f of x. Okay. This function is just, I haven't really said anything more other than it is a math function, negative 3x squared plus 5x. Okay. And there is a value given, a is equal to 10, and then there's a value h is equal to 1, right? So what we have on the screen is all that we need to find f of a plus h approximately. We have everything on the screen to find that. We know it will be f of a plus f prime of a times h, okay? Now we know that this approximation, the approximation might not be too good because this h value is pretty big. Pretty big at h is equal to 1. We know that we got really good approximations when we did h is equal to 0.1 or 0.001. Better approximations when h is equal to smaller, 0.1, and h is equal to 0.001 or something like that, right? But for the purposes of section 3.1, the marginal concept, it will be important. The marginal concept, the big idea here is that we're going to let h is equal to 1, as you will see shortly why we do that, okay? So if we continue with this problem, this approximation problem, we can see everything we need in this picture. We have chosen an a value of 10. We've got the function in blue. We've got the tangent line in this orange color. And we know that if we want to find the function evaluated 11, right? On this picture, the function evaluated 11, the blue curve is somewhere down around negative 300 something. And we can see on this table that the function evaluated at 11 is exactly negative 308. That's the exact answer. Okay. But if you want to approximate that, this will be approximately the function evaluated at 10, okay, plus f prime of 10 times 1. And because there's a 1 here, this computation is pretty easy to do. The function evaluated at 10. Sorry. This f of 10, this is an exact number now. F of 10 is about is 250. Okay. And the f prime of 10, we still need to find f prime in this problem, f prime of x, is going to this 5 minus 6x. You could find that with Pascal's triangle and the f of x plus h expansion. So f prime of 10 is 5 minus 60, otherwise known as minus 54. So the function evaluated 11 is negative 308, but that is approximately negative 250 minus 54, which that number is about minus 304. So we can see that here, if I zoom in on this part of the plot, right, you have the function in blue, you have the tangent line, and the function evaluated at 11 is minus 308, but the approximation is this point on the line, minus 304. Okay, so that's what we were seeing right here on this picture. Okay. Now, that is the mathy problem. It's just a given function, a value, and an h value. Okay. The marginal concept comes in the following form. Let me make this a little bit bigger. Okay. Make this a little bit bigger, and then I can bring in the problem that would be listed in section 3.1. So here, compare now that they've given you a function. Okay. Let me make this a little so you can see all of it. So here they've given you a function in this problem, section 3.1. They've given you a revenue function, R of Q. Okay. So this is the revenue, the amount of money that you bring in for selling Q widgets, whatever they may be, widgets, Q widgets. Okay, and this is the particular function minus 3q squared plus 5q. Okay, so instead of, all we're seeing here is that instead of x's, we're using the variable q instead. Okay, but it's the same function, except x has been replaced with the q for quantity. Q equals quantity. In this case, the quantity of items sold. Okay, now here's the question. Okay, in the above problem, R of 10, this is the amount, this is the revenue for selling 10 items. Okay. And according to us up here, when you plug in 10 into that function, you get negative $250. Okay, so this is bad. Minus $250. All right. So you've kind of lost some money on this transaction. So the cost, kind of the money that you've brought in, is saying you're still owing somebody money to make these gadgets. Okay, we'll come up with better numbers in a second. So R of 10 is minus $250. Okay, the question is R of 11, right? What is the revenue for selling 11 items? And notice that 11 is 10 plus 1 items. Okay. So it's interesting to note that according to our approximation formula, R of 11, that is approximately the revenue for selling 10 items, okay, plus the derivative of the revenue function for selling 10 items, times h, and in this case, h is equal to 1, because we are trying to sell one more item. Okay. So that's what this approximation formula is for. You can approximate your revenue for selling. This is the approximation in revenue for selling one more than 10 items. Okay. So we now have that number that the revenue for selling 11 items is approximately, what was that, minus 308, 304. Okay. This will be approximately minus $304. So this is bad. To sell more items, our revenue is going down. Okay. The exact value to sell 11 items was minus $308. Okay. And so this approximation is about that number. Okay. So enter now this is how the question can be asked. What is the revenue if one more item is sold than 10 gadgets? Well, the revenue for selling 10 gadgets was minus $250. So to sell one more than 11 items, that would be minus $308. And this is the approximate value for selling one more item than 10 gadgets. Okay. So here comes the marginal concept. The marginal concept, we need to introduce this the marginal revenue in this case idea. So let me minimize this, and then let's bring back up a little bit more room here. Okay. So let's bring up the marginal revenue. Okay. What the marginal revenue is essentially the basic idea. The basic idea is that it is a difference in two revenues. Okay. So for example, in this problem, you could have the revenue for selling 11 items minus, or the difference in selling 10 items. Okay. So this is the difference in revenue, okay, for selling one more than A is equal to 10 items. Okay, so that's what this says. It's a difference. You're selling 11 items, which is one more than 10 items. Okay, so then you could see here that the difference in this case would be minus 308 minus revenue for selling 10 items was minus 250, okay, which is minus 308 plus 250. The minus and minus make a plus, and so what is that? Minus 48. Okay. So you have two ways to designate this. Minus 48 is R of 11 minus R of 10. Okay. So rather than always write these differences, this number right here, this has a name. This expression, this difference of two revenues has a name, and it's called the marginal revenue. It's called the marginal revenue. Okay. To be more exact, it's the marginal revenue in, and so you should probably add this on, the marginal revenue in selling one more than A is equal to 10 gadgets. Okay. So sometimes you will see this called MR in the book for marginal revenue. It's R of 11 minus R of 10. The marginal revenue in selling one more than 10 items. Okay. Has a little bit more of a notation. I would prefer to write marginal revenue of 10. Okay. Instead of just MR, marginal revenue of 10. This is saying that your Marginal revenue, you're trying to sell one more than 10. You're trying to figure out how much more money you're going to bring in. This is how much more money. How much money, how much more money you bring in by selling one more than 10 items. Okay. So it turns out in this case that you don't actually bring in more money, you actually lose money. So in this example, the marginal revenue in selling one more item is actually going to cost you minus $48. Okay, so you actually lost money by selling one more item because presumably you had to actually build these items and they cost you more money. Okay. So this is what we have, the marginal revenue concept. It is a difference in two revenues. Okay. So if I was going to look at another example, let's say, from the book, where did that go? Let's see. Okay. What is the revenue if one more item is sold than 37 gadgets? So this is the wording from the book. Okay, what is the revenue if one more item is sold than 37 gadgets? Okay, so we are talking about the revenue. Okay, so we have our revenue function again. You have your revenue function. Same function as before, so that hasn't changed, minus 3q squared plus 5q. Okay. What is the revenue if one more item is sold than 37 gadgets? So that would be, you would have to find the revenue of 38 gadgets. That's what it is asking you, the revenue in selling one more than 37 gadgets. Okay. So we can find that exactly. You just plug in this number 38 into that function. Okay. There would be a similar idea. So this is the revenue in selling 38 gadgets. Okay. If you want the marginal revenue for selling 37 gadgets, this is the marginal revenue. Well, you would have to look at a difference of two revenues. Okay. Revenue 1 and revenue 2. Which revenues do you use? The marginal revenue at 37 items, that has the connotation that you need to find the revenue for selling 37 items, and then you need to find the revenue for selling 38 gadgets. Okay, so this is the special case A. Here's your A value. This is A plus 1. And here is A again. So your marginal revenue in selling A gadgets, the marginal revenue for selling A gadgets is the revenue to sell one more minus the revenue to sell A gadgets. Okay. So I think we could probably compute these numbers here. Right, you could work these numbers out, and as well as I can. Let's see here. So what's going on here is we have not changed our function. We now want to change our A value to 37, and H is always 1 here. Notice that the difference between these two values, A plus 1 minus A, is equal to 1. That is your H value. So when we're talking about marginal revenue problems, we're always talking about an A value, an H value of 1. So if you change that to 37, rerun these numbers. Okay. Let's see. You get a revenue, okay, when A is 37, you get a revenue of, at 38, you get minus 4142 minus your revenue for selling 37 gadgets, that's your X value, minus 3 922, right? And so you do 4148. Then you add that to 3922. And whatever you get for that number is your marginal revenue for selling one more gadget than 37. That's called the marginal revenue of 37. Okay.